In lesson 3, you learned how to take 0 to 5 volt analog readings on an Arduino. But what if you wanted to measure higher voltages? A battery, for example, or perhaps a solar panel. How would you do that? Well, in this video, you're going to learn not only how to measure high voltages, but also how to measure currents. To help us with these measurements, we're going to use a voltage divider. This particular one allows you to measure up to 25 volts. And for current measurement, we will use this ACS 712 module that comes in 5 amp, 20 amp, and 30 amp versions. This device is very simple to connect to the Arduino. The minus goes to ground on the Arduino, and the S goes to analog input channel 0. Now the code for this is incredibly simple. We just have a variable here called voltage, and the type is float. That allows us to have decimal points. In the setup loop, we are just going to start the serial monitor so that we can read the voltage. And then down here in the loop is our main command where voltage equals the float of the analog read A0 times 25 divided by 1023. Now, normally for Arduino, this would be a 5 instead of a 25. Because we have this voltage divider, we can go up to 25 volts. And 1023 because that is our number of steps in our revolution. Then we can simply serial print the voltage and display that. And we'll do that every 1 second. So let's test this out. We've got the code deployed to the Arduino. And we need to start the serial monitor. Zoom in a little bit on that. Okay, so now we're reading our voltage. I've got a 9 volt battery, a 12 volt battery here. Let's see what we read. I'll start with the 9 volt first. And as you can see, we're getting about 9 volts. Let me switch to the 12 volt battery. And 12.4. So it looks like it's working great. Now, what if we want to go higher than 25 volts? Well, that is easy to do using this formula here, where we can change resistor 1 and resistor 2 to get an output voltage that is less than or equal to 5 volts. So using this little handy calculator here, for example, we want our output voltage to be maximum 5 volts. Say we picked a 100 kilo ohm resistor for R1 and a 5 kilo ohm resistor for R2. Then we can just click on this calculate button, and that would allow us to measure voltages up to 105 volts. So very versatile, very powerful tool that you can use along with your Arduino to measure high voltages. Connecting the ACS 712 is also very simple. Ground on the unit goes to ground on the Arduino. Out goes to analog input channel 0, and VCC goes to 5 volts on the Arduino. Now on this side we have our red and black wires which will connect to our load. Now our code for measuring current will be very similar, except first off we have 2 variables, voltage and current, and same serial begin in our void setup. So first of all, we're going to measure the voltage detected on the analog channel A0, and we're back to 5 volts since we're no longer using a voltage divider, and this should actually be a 1023, my mistake. The current will equal the voltage minus 2.5. Now, that is because this device is capable of measuring both negative and positive current, so a voltage of 2.5 equals no current. And then we simply divide that by a factor that is in the data sheet for the ACS 712. For the 20 amp, which I'm using, we're going to divide by 0.1. For the 5 amp, you do 0.185, and for the 30 amp, you would do 0.66, which will get you your current value. We're going to display those to the serial monitor once per second. All right, so let's use our code to test out this used solar panel to see if it's any good. On the back of each solar panel should be a sticker containing the electrical ratings. And today we are going to test the open circuit voltage and the short circuit current using our voltage and current programs that we just wrote. All right, so I got the serial monitor running. Going to connect the Arduino pins to the solar panel, and it looks like we're getting 21, almost 22 volts, which is pretty good. The clouds are out a little bit, and it's a little later in the day, so we wouldn't expect the full 25 that's shown on the sticker. But this is pretty good. All right, now we switch sensors and switch programs to our current monitoring. And now if I connect to the positive and negative, I'm getting almost 10 amps, which is pretty good. Now I'm going to switch the leads just to show you something. If I reverse positive and negative, now I'm getting negative amperage, which this sensor is capable of measuring in both directions, as we discussed earlier. And that's a good way to know if, say, for example, a battery is charging or discharging. Well, that's it for lesson 4. Stay tuned for lesson 5, in which we will learn how to use the Arduino to measure the position of a joystick. See you then.